So all the companies, many companies are doing POCs now on this GPT, and they are looking for the people who is having knowledge of these prompts, how to make a prompt. I'm going to mm, mention what is a prompt and what is this algorithms, GPT, transformer, and BERT. What are all these algorithms? So people are looking for, companies are looking for the people. So these kind of applications we can build in the organization. They are building the applications. So prompt engineering, generative AI, GPT, large language models, these are all related to same field. These are all related to same field. Same field. Prompt engineering means, I mentioned one prompt just before. If we give a full page document and we want to summarize to 50 words, this is one kind of a prompt. This is called one kind of a prompt. It is going to summarize and give us. So this is one kind of a prompt. Suppose there are some more prompts I'm going to demo it. Like for example, I want to know about quantum physics. What is quantum physics? If I ask a question like this, it is going to answer. This is a simple prompt. I can ask question, what is a HIV virus? Tell me in French language. The virus is a HIV is a variable here, and the language French is also variable here. If we with same prompt with different combinations, we can ask, and it is going to respond. These are all the different prompts. Means the way we interact, we interact with these algorithms, uh, yeah, the similar way it is going to respond. With an optimized prompt engineering is an optimized way of asking questions, asking using applications in a GPT models, in a GPT models. Okay, so that is a prompt engineering. So what is, so how to use a model, that is we can ask questions and we can do that. Okay. So we should also know, we should today, okay, if we learn today prompts, how to write a prompt, it is fine. Tomorrow, the algorithms might change, because they are continuously improving, right? So last year it was 2.0, now it is 3.5, and 4.0 is already coming. So this is continuous level. So we should know about these algorithms also. We should know about these algorithms, and uh, we should make changes in the algorithms also. So we should know about them. So this course is basically two parts. One part is how to use that algorithms using the prompts, asking correct questions. That is one part. And the second part is the algorithms. What are those algorithms and what is the technology behind these two? These two are the main parts of this course. Data science. Why I am putting this data science slide? You can ask me here. So far, we are talking about language, we are talking about GPT, and how data science is related to GPT. So GPT is one algorithm which is an advanced algorithm related to deep learning, which is an advanced algorithm related to deep learning. Okay. So how deep learning has come, how machine learning has come, these are all the things we should know. So artificial intelligence means the name itself is an artificial intelligence. Intelligence, the way humans think, the humans learn, it will be done by the computers. That is the reason it is called artificial intelligence. So deep learning is exactly the same. Our brain neurons connected same way. This neural networks will be deep learning neural networks will be neural networks will be trained. So what is machine learning here? Machine learning is a statistically optimized learning. Statistically optimized learning. Okay, that is called machine learning. That is the difference between. So GPT is part of the deep learning. GPT is part of the deep learning. We are going to learn machine learning, we are going to learn deep learning, and other parts also we are learning. Data and learning. What is the data? What kind of data we have? We have structured data, semi-structured data, unstructured data. Structured data, semi-structured data, unstructured. Structured data means which is there in the tables, that is called structured data. Semi-structured data means the data which is there in the log files. Unstructured data means the data which is there in the emails, tweets, poems, essays, web pages. These are all called unstructured data. Learning is basically three types of learning: supervised learning, unsupervised learning, and reinforcement learning. So supervised, so if we know the target earlier itself, then that is the supervised learning. Unsupervised learning means recently we have gone through this COVID scenario, right? So the virus which has come, nobody knows about it. So they clustered this virus behavior with the earlier virus behavior, like typhoid and other, I don't know, other diseases, and doctors treated us. So when we are dealing first time, we are going to use unsupervised learning. So that is reinforcement learning means based on the environment, our actions will be there. That is a reinforcement link. For example, if you are going on a road, on a bike, the person which is going on a bike before us, if you fall on a pothole, we won't take that path. We will take a different path, right? So that is the learning. We are learning from the environment. So this is one example, reinforcement learning. So GPT uses reinforcement learning. GPT uses reinforcement learning. Okay. So data is there. Can we directly apply models to it? Can we directly apply it to the models? So some data are in strings, some data in words. Can we directly apply? No, we cannot directly apply models to the words. We have to convert into proper words. We have to convert into proper words. Okay. So convert into proper words. So that is part of the feature engineering. So feature engineering means we have to process the data first, then only we can apply it to the models, like outlier processing, scaling, encoding, resizing. All we need to do. Outlier processing means, suppose if we are working on a problem like salaries of all the employees in India. If you try to make a plot, the, the people like the big businessmen like Adani, they are the big people, right? They have big businesses. They are the rich people. Their salaries are very high compared to our normal salaries. That means their salary is an outlier in our salaries. That means that kind of data points we need to process it in a special way. Okay, in a special way. So that is the need of outlier processing. Imputing data means if when we are collecting data from different resources for any network reason or some other reason, if you could not collect some part, suppose if you are collecting data of an employee, if you know his date of birth, if you don't know his date of birth, we know all the details. What we could is we will impute it, but means we'll make an assumption based on the current data, like mean or mode or like that, and we will do fill that data. We are going to fill that data. This is called imputation. These are all the different things. They are the different things in the feature engineering. Before applying models, we will be doing in a data. We will be doing this. This is about feature engineering. Machine learning is what I mentioned, the statistical way of learning. There are three kinds of problems will be there in this: regression, classification, and clustering. Regression means, suppose we are applying for a loan of some bank, HDFC, ICICI, any bank. We will go to web page and if you, when we are applying to the loan, it will ask for the data, right? It will ask for the like, what is my date of birth, what is my monthly salary, what kind of job I am doing. These kind of questions it will ask. Once we give all this data, it is going to uh, apply to the model, and it will respond back. There are two parts it is going to respond. One is I am eligible for loan or not. Yes or no. Means it's a target is discrete. Means that is a classification problem. If yes, I am eligible for the loan. How much? How many lakhs I am eligible? I am eligible for 10 lakhs, 15 lakhs, 5 lakhs. The target variable is a continuous variable. So that is called regression problem. Clustering. Clustering means label unknown. This is a COVID scenario, right? So we don't know what kind of medicines to be given, and they clustered with earlier scenarios, and they have given medicines. That's called clustering technology. So we need to know different learning mechanisms. That is the reason we will cover machine learning part also. Next comes to deep learning. Deep learning means the right side we could see biological how neurons will be connected. So similarly, artificial neurons will connect in this way. Different layers will be there, different weights will be there, different nonlinear functions will be there to learn the situation. So same thing, whatever is there in the biological neuron, we will connect it to artificial neurons, and we will do learning. That's called deep learning. Deep learning is the initial way of artificial intelligence. Later came this machine learning and other things. Later it has come. So what are the different algorithms in the thing in the deep learning? One is a convolution neural network. Convolution neural. If we give an image to an algorithm, what it is going to be? It is a cat or a dog, or that's an example, cat or a dog or monkey. So it is going to give. So that is an algorithm. LSTM is a long short-term memory. That's what I'm mentioning. LSTM, like translation. Google Translate was using LSTM 10 years before. 10 years before, not now. So that is LSTM, long short-term memory. Okay, let me give what is the advantage of LSTM. Let us take three scenarios here. First one is people talk dash language in Paris. Dash language in Paris. That means French language in Paris. That means LSTM can understand the context of the sentence, because Paris is there. Paris is in France, and in France, French languages will be spoken. So that is the reason it will fill the blank with the French language. Let us take the next scenario. If I get a message from my manager, let us resume discussion today. So here the word is resume. Resume in this context, resume means is a verb. He would like to continue the discussion. That's what he means. To see another message which came from HR: find attached resume for the position of the data scientist. So resume, here also the resume word. Here the resume is a noun. So here is a resume. So LSTM can understand the context. And LSTM can understand the context and give predictions. That's how we were getting Google Translate working 10 years before. 10 years before. So let us continue. Let us continue with other things. Natural language processing. Natural language is like a text or a paragraph, right? So we have to process that paragraph into numbers. There are different methods are called tokenization. Tokenization means splitting the paragraph into words. Stemming means understanding the root of the word. Processing, right? Processing root word is process. Stemming, lemmatization. Lemmatization is also similar to stemming, but it has higher accuracy. It has higher accuracy. It takes more time. That is lemmatization. Word embeddings. Word embeddings. When we give a paragraph like this, it is going to give a vector. It is going to give a list of vectors, That vectors we are going to process in the uh, algorithms. So this is the introduction about uh, natural language processing. Now comes the deep learning models. So in maybe your friends or relatives are there in countries like US, they are having driverless cars. In India, it is not there yet, but in US, it is the US and Europe. So what algorithms they are using? They are using computer vision algorithms. So in the left side is a street. It's a street. Picture has been taken. And if you give that picture to this algorithm, it is going to recognize so many objects: people, handbag, bicycle, car, signboard. These are all the these are all the items it is going to recognize, and accordingly, the speed, high speed, left, right turn, left turn, everything will be decision taken by a driverless car. So the algorithm used here is the computer vision algorithm. Algorithm named is YOLO. Current version of YOLO is V5 or V6. So that is the advanced deep learning computer methods. And other advanced deep learning method for the natural language processing is called transformers. Transformers. So it is similar to LSTM, but not completely similar. LSTM, the training happens in a sequential way. But transformers training goes in a parallel processing. And there is one more thing got introduced here is attention. Attention. I'm going to give one example on the attention. There are two sentences here. The animal didn't cross the street because it was too tired. It was too tired. Here, it is referring to animal. It is not referring to street, because street cannot be tired, right? That means that is the attention mechanism. So I will change the example again. The animal didn't cross the street because it was too wide. Here it refers to street, not refers to animal. Means attention means it understands very deeply about the context. What this kind of pronouns actually referring to, the actual sentences and words in an algorithm. So this is called attention mechanism. So this is attention mechanism, and these are the two things which is uh, uh, introduced. There are the two blocks in this. Left side block is an encoder block. Right side block is called a decoder block. Using this transformer, we can build questions, answering, text generation, text summarization. These are all we can do. The GPT also generated pre-trained transformer. The transformer what I was referring to is this one. So GPT is a modified version of this transformer. Modified version of this transformer. Okay. Another advancement is BERT algorithm. Another advancement is BERT algorithm. Okay. BERT algorithm. So this BERT algorithm is a stack of encoders. Here we can see there is left side there is an encoder, right side is a decoder. So what they did is they removed this decoder and they stacked 12 or 16 layers of encoders they placed here. Back to base, they have 12 layers. In back to latch, they have 24 layers. So what is the advantage they get? So they get a BERT algorithm can understand two ways of context. One is the left to right, right to left. So why do we need left to right to left? Why do we need right to left? So most of the people will write left to right. So suppose we are working on a sequence problems like stock predictions or temperature predictions. If you want to know the situation before last 1 year, before 2 years before, we don't have the data. Using this BERT algorithm, we can learn. Okay, and one more algorithm. This is a bidirectional algorithm, encoder algorithm. and a few short learning. That means unlike LSTM, it needs few cycles of training. That is the reason it is called few short learning. It's a BERT. Okay, and the GPT, our main interesting topic, is a generative pre-trained transformer. It is decoder stacked. So they removed encoder from the transformer. They have added decoders line by line, and they build it GPT. It's a one-shot learning. One-shot learning means at one shot it is going to learn. It doesn't need many iterations to learn. So that is the advantage of GPT. That is the advantage of GPT. The case studies which I was mentioning, which I already shown, and job opportunity. So this is the end of my presentation. Uh, any questions or anything? Again, we are open for the discussion. Rajnikant, you can ask the question.
Sir, can I ask one question?
Yes, please.
Hello.
Yes, please. Yes.
So can you give me some real-time example for this image, audio, video applications where we use? I mean, what suppose a real customer is there, so they needed this kind of requirement like images, audio, video application, some sample. Can you give me a real-time example? Let's
Real-time
suppose one
application,
customer is
real-time.
there.
Yes.
Let's suppose one customer is there for their requirement is like this, like this. So can you give me, and have we developed some kind of applications like that where we are doing
Audio
images?
video, GPT just released last month. So we are not yet there. Audio video, we are not yet there. It is there. Maybe by the time we complete this course, we may do that. Audio video, it is not yet there because they released the GPT algorithm itself 3 4 weeks back. So it will take little time. Maybe 3 4 months, we will definitely build an application. That's not a big deal.
And one more thing is, sir, already see this chat GPT and other, so many things are there. They're already doing the, image and audio, video, everything, right? Suppose if you give the audio, they will give the text or image or video. Everything is already, it's a open. So my question is, so as a developer, so should only I need to be use that interfaces? Let's suppose client is came to me and he asked me to be develop some application. So what kind of what is my role? So just I need to be connect the OpenAI some any other thing and have a send the API to them and get the services, that only thing, or we need to be develop same what AI is doing same thing, we need to be develop our own thing. So that's my question.
Suppose, suppose companies like Microsoft or Facebook, their policies and their processes are all private. They don't want to expose those details outside. So they want their own custom application. They don't want to release their data to OpenAI. So we
Correct.
need to build applications locally for the organization. There is endless of scopes are there.
Mm-hmm.
There are many people are doing nowadays this activity.
Okay, okay. So even a small customer also will get like this. They want, I have a requirements, or they are going to be use only this public domains for these things.
Small customers means small customers. They don't think they need a custom chatbots. They mostly they will be dealing with the OpenAI. So
Yeah,
for them, we go for OpenAI kind of things. And for the larger organizations, they need a data privacy laws are very strict. They have. So for them, we have to build these kind of applications, custom chatbots.
yeah, I understood.
There are many opportunities are there in this side. There is a lot of scope. There is a lot of scope. It's good to interact with all of you. Thank you. Thank you. Bye bye.